Now the next identity is a plus b plus c the whole square. What I was talking about before the factorization, that is 3 quantities the whole square. This is a plus b plus c into a plus b plus c. The expansion of this a plus b plus c the whole square is a square plus b square plus c square plus twice ab plus twice bc plus twice ca. Now, in this also there is variety. Means what? We can change the signs. Means only a is negative, or only b is negative, or only c is negative, or in the combinations b and c are negative, a and b are negative, or a and c are negative. In that case, in place of wherever a, b and c are falling, we have to put minus sign. So in other words, we can say, suppose the first type I am taking for this, only a is negative. So the expansion will be, these 3 quantities will always be same. That is a square plus b square plus c square only. Why? Because whether this quantity is positive or negative, its square will be positive. So there will be no change in these 3 terms. The change will come in last 3 terms according to the sign. So where a is falling? Here and here in the last term. So those 2 terms will be negative. Either you write it directly negative or you substitute minus a in place of a. So both the ways I am giving you. Either you write it like this, means in place of a you write minus a, because here this is minus a. So ultimately the expansion will be, in place of this plus now, this will become minus. Why? This positive and negative will make this term negative. So minus twice ab plus twice bc again. This is positive, this is negative. So this is the change. Clear? Now minus a, the same type. If we will take the combination, that is, if b and c both are negative, let's see the expansion. So a minus b minus c the whole square. Wherever b and c are falling, we can write them in place of b and c, minus b and minus c. So let's see, this will be a square plus b square plus c square. As I said, these 3 terms will be as it is. Now b is negative, so twice a into minus b. Again b is negative, as well as c is also negative. And here last term c is negative, a is positive. Now if we write the expansion, this will be a square plus b square. Now plus and minus will make this term negative. So this will be minus twice ab, but this term, both the terms are negative, so minus into minus will be plus and plus into plus will be plus. So plus twice bc, and this will be plus into minus will be minus 2ca. Now you see this and this, they are same. So that is, this c square is left out. A square plus b square plus c square will be as it is. Now look at this expansion and this expansion. A square plus b square plus c square minus twice ab plus twice bc minus twice ca. But this is the expansion of a minus b minus c the whole square, and this is the expansion of minus a plus b plus c the whole square. What does it mean? It means that these 2 are equal. So the conclusion is minus a plus b plus c the whole square and a minus b minus c the whole square are same. So we can write it as minus a plus b plus c the whole square is also equal to a minus b minus c the whole square. It means that if the first term is negative or other two terms are negative, the expansions will be same. On the basis of this, we can conclude next two results also. Means if only b is negative and a and c are negative, the expansion will be same. So I'll just give you that. The other two types will be a minus b plus c the whole square will be minus a plus b minus c the whole square. Or the third is if a and b are positive and c is negative, or a and b are negative, the expansions will be same. So this is something new we are learning, that whatever is the expansion of minus a plus b plus c the whole square, that is same. Why is this so? Because wherever b and c are falling, that term will be positive because both of these are negative. And in the expansion of this also we saw wherever b and c was together, that was positive. That is why these two are equal, these two are equal, and these two are equal. One more interesting thing is there. That is, if all three terms are negative, then we can say this is also equal to. So these are also the results related to the same identity, that is a plus b plus c the whole square. Now we'll see how can we apply the identity a plus b plus c the whole square. If the question is 3a plus 4b plus 5c the whole square, we compare it with a plus b plus c the whole square, and the expansion is a square plus b square plus c square plus twice ab plus twice bc plus twice ca. Now in place of a it's 3a, in place of b it's 4b, in place of c it's 5c. So we'll take the term 3a as one term. So now the expansion will be first term square plus second term square plus third term square plus twice ab, means two times first quantity and the second quantity. So this will be twice first into second quantity plus twice bc, means two times of this into this. So that will be 2 into 4b into 5c, and the last is 2 times of ca, means the last term and the first term. So that would be 5c into 3a. Now the overall expansion will be 3a the whole square is 9a square, then 4b the whole square will be 16b square plus 25c square plus 2 into 3 into 4. So 6 into 4, that is 24ab plus 2 into 4 8, 8 into 5 40 bc plus 2 into 5 10, 10 into 3 30 ce. So if all three terms are positive, all the terms in the expansion will also be positive. If any term is negative, for example, in place of this, if the question is 3a minus 4b plus 5c the whole square, expansion is same, but in place of 4b, not in these three terms. There will be no change in these three terms because they are the squares of the numbers. If you are writing minus 4b the whole square, that will be 16b square only. The change will come in last three terms according to whichever term is negative. Now this middle term is negative. So wherever 4b will fall, that term we will write as negative. So overall this term will be negative and this term will be negative. So according to the term which is negative, in the same expansion of a plus b plus c the whole square, we can write that term as a negative term, and according to that the sign will change. So first we saw how to write the expansion of a plus b plus c the whole square, and this was the expansion. Now if the question is opposite to that, means factorize. So in the expansion of identity, this is the LHS and this is RHS. When LHS is given and asked what is the expansion, then we will write it like this. But if suppose it is asked factorize, it means right hand side will be given. Then we have to find what are the factors of this given expression. Whenever we write the factors, we write in its linear factors, means product of the linear factors. Ultimately, answer should be like that. So it means this given expression is to be expressed in the form of product of its linear factors. So if we talk about this a plus b plus c the whole square, so a plus b plus c the whole square is basically a plus b plus c into a plus b plus c, means the factors of this expression are a plus b plus c into a plus b plus c. So same way, if the question is this, then we have to go back to the left hand side. Now, when the question is given in this form, we will check the signs very first thing. So two terms are negative. It means that out of these three, any term should be negative, then only it is negative. So now we will check what is common in these two terms. The common variable is y. It means the middle term is negative. Now let's see how we will write the factors. First three terms are always the squares. So first we will write 4x square is a square of 2x. Now this y square is a square of y. But we can see here in these two terms y is negative. So we will write this as minus y the whole square. Z will be as it is. Here we can write it as, compare it with this, plus twice ab. So twice into first term. First term is 2x and second term is negative. Because of this negative minus with this y, this term is minus 4xy. Similarly the next one, plus 2 into second term into third term. Now second term is negative, so that we will write into z, plus 2ca. 2ca means 2 into third term into first term. The third term is what? Z, and the first term is 2x. So now compare it with the given expression. This is a square plus b square plus c square plus twice ab. So in place of this y, what we have written over here, plus twice a into b. b is the second term which is negative. And how did we find that? Because these two terms are negative and the common variable which is y, that should be negative. So ultimately what have we observed? This whole expansion is the factorization is in which form? A minus b plus c the whole square. Why a minus b? Because the second term is negative. So now this we can write it as 2x minus y plus z the whole square. So ultimately it should be in the form of the product of the linear factors. So this we will write in this way. So the factors of the given expression are a minus b plus c into a minus b plus c. Now what we had discussed earlier, that the two expansions a minus b plus c the whole square and minus a plus b minus c the whole square, they are same. So if you notice, the same answer can also be written as minus 2x plus y minus z the whole square. Means Either the second term negative or first and the third term is negative, the expansion will be same, that we had already discussed previously. Clear? So answer is this or this, both are correct. Clear?